Hello everyone, this is Katish here. In this video, I'm going to go through the AQA Physics Paper 2 Foundation Tier from 2025. This is the latest paper. This is from the Combined Science. Now this paper 2 is 1 hour 15 minutes long and it has 7 questions and it's tested on 3 main topics, which is forces, waves, and magnetism and electromagnetism. So question number 1. Question 1. Figure 1 shows a person about to dive from a high platform into a pool of water. So you have an image showing the platform and the person on the platform and the water as well, labeled. The person dived from the platform into the water. The time taken between the person leaving the platform and entering the water was measured by 4 people. The measurements were 2.1 seconds, 1.9 seconds, 1.3 seconds, and 2 seconds. Which measurement is anomalous? Now, the word anomalous basically is referring to any measurement that might be, hold on one second. I've highlighted this word anomalous. Any value that you take as a measurement which might look as incorrect. So as you can see, 2.1 seconds, 1.9 and 2 seconds, they're all very close to each other. And this 1.3 second looks like is the anomaly because it's way too low compared to the others. So the answer is 1.3 seconds. 1.2, air resistance acted on the person during the dive. Figure 2 shows the person moving vertically downwards. So they have 4 forces which is labeled. So because we are going to be doing as a bit of revision as well, let's label the forces. This A is the air resistance. Air resistance. Now you could also label it as drag. Now the force acting down is the weight of the person. Now there's usually no sideways forces B and D acting on a person when they're falling straight down, unless it's the direction of the wind blowing in either way. Which arrow on figure 2 shows the direction of the air resistance acting on the person? That should be A. Air resistance is a contact force. Which force is also a contact force? That would be friction. Gravitational and magnetic force are both non-contact forces. Forces. What happens to the size of the air resistance force as the speed of the person increased? Now, as the speed increases, the air resistance also increases. So, as speed increased, air resistance also increases. After entering the water, the person decelerated for a time of 0.35 seconds. So decelerated basically means to slow down or slowing down. For a time of 0.35 seconds. The deceleration of the person was 60 meters per second squared. Calculate the change in velocity of the person. Now they have given you the equation. Change in velocity is deceleration, which is this 60 value. Now you're not going to be squaring it because the equation doesn't say anything about squaring, so it's deceleration. So that is 60 multiplied by 0.35. That should give you an answer of 21 meters per second. The mass of the person was 75 kilograms. So the mass of the person is 75 kilograms. Calculate the resultant force on the person when the deceleration was 60. Use the equation. So again, they have given you the equation. Resultant force is mass, which is 75, multiplied by the deceleration, which is 60. That should give you 4,500. That's 4,500. 500. That brings us to the end of question number 1. Let's have a look at question number 2. Now, question number 2 is on the topic of waves. Food coloring can be used to change the color of water. A student investigated how the color of water affects the time taken for the water to cool. This is the method used. Pour 200 centimeter cube of hot water into a conical flask. Add 4 drops of food coloring to the water. Place a digital thermometer in the water. Start a timer when the temperature of the water is 80 degrees. Record the time taken for the water to cool to 65 degrees Celsius. Repeat steps 1 to 5 using different colors of food coloring. So in figure 3 shows the apparatus used. You have the conical flask with the colored water, the digital thermometer showing 80 degrees and the timer at 0. What is the independent variable in this investigation? Now the independent variable is what you would change, right? Here they're changing the color of the water. Okay. Now the final temperature is actually going to be your dependent variable. And the volume of the water is actually your control variable. Pull it up a little bit. Control variable is what you don't change. Dependent variable is what you measure. The independent variable being the what you change. And control variable you keep the same. Next part of the question, 2.2. Which of the following was a control variable? That was the here initial temperature of the water was also the control variable because you started at 80 for each of them. The type of thermometer used. Now, the type of thermometer used was the digital thermometer. Let's have a look. Now, usually the type of thermometer used, we often say use the same equipment as control variable, but even if you did use a normal analog thermometer with the mercury or the alcohol thermometer, the line going up, you'll still be able to measure 80 degrees Celsius. So here the initial temperature is the best answer. The time taken for water to cool is actually your dependent variable. What equipment should have been used to make sure 200 centimeter cube of water was put in the conical flask? Now a beaker is not doesn't have the best resolution. The best is actually the measuring cylinder. A meter ruler is not going to be able to measure water volume. The student also tested water with no food coloring. The temperature of the water changed from 80 degrees to 65 in a time of 5 seconds. So here you're starting at 80, it went to 65 in 5 minutes. Calculate the average change of temperature of the water. Use the equation. Again, they have given you the equation. They're asking for the change in temperature. Now the change in temperature is gone from 80 to 65. So you need to work out the difference first. So 80 minus 65 would give you 15 degrees Celsius. So that's 15. Now the time taken here, if you look at the units, they are per minute. So you don't really have to change it to seconds. So that's 5. That would give me 3 as the answer. 3 degrees Celsius per minute. Table 1 shows the results for the for the different colored water. So you have red, yellow, green, blue, violet. Rate of change of temperature in degrees Celsius per minute. Complete figure 4. You should label the y-axis. Add a scale to the y-axis. Draw bars for the green water and the violet water. So let's have a look at the bar graph. They've already given you red, yellow, green, blue, and violet. They're asking you to label the y-axis. Now, if you look at the table actually gives you what you should actually label that as. That should be, here you can see color of water at the bottom. That is the first column. The second column is the y-axis. So here you would label this as rate of change of temperature in degrees Celsius per minute. You would simply copy that. You don't call it y-axis and x-axis, but I'm just labeling that just for clarity. Now let's have a look at drawing the bar graph. So you can see the width of the bar is actually 4 boxes. So you'll have to have 4 boxes for the green. The green color is 4.3. So before we draw the green box, we have to label this. So red is 6.1. So I say that's 1, 2, 3, that's 4, 5, 6, and that's gone by point. Oh, okay. So that's correct. So 6.1. This is 6.1, and this is exactly at 5, and the blue is at 4. So the green should be 4.3. Now each box in the y-axis is actually 0.2. How do I know that? I've got 5 boxes, so 1 divided by 5 is 0.2. So each box is 0.2. It goes up as 0.2, 0.4, 0.6, 0.8, and then 1. So green box needs to go up to 4.3, which is 4.3 is half of 1.5 box. So if I draw a line there, let me redraw that. Oops, yeah, there you go. And then straight down. Ideally, you want to use a ruler. That's 4.3. The violet is 3.7. So that's 3.7 is going to be, that's 3.6 and 3.7. Just straight now. There you go. That's 3.7. And in the visible spectrum, orange light is between red light and yellow light. Estimate the rate of change of temperature if orange food coloring was used. So if orange is between red and yellow, if it's between these two colors, so let's say orange is here, right? Now if they're asking you to estimate, so if I draw a line, right, straight from the tip, let me get rid of that. So if I draw a straight line from this, straight line, hold on. There you go. And if I mark that halfway between, that is about 5.6. That should be enough. So we'll write the answer as 5.6. Now the marking scheme actually will accept any answer between 5 to 6.1. Complete the sentence. Choose the answer from the box. You have infrared, ultraviolet, X-rays. The results show that the color of the water affects the rate at which the water emits, and that should be infrared radiation. It'll never emit ultraviolet violet or X-rays because it's not hot enough. Complete the sentence. Choose the answer from the box. Energy, rarefactions, and temperature. The water in each conical flask cools down because the electromagnetic radiation emitted by the water transfers, and that would be energy. That brings us to the end of question number 2. Let's have a look at question number 3. Question 3 is on the topic of forces. A student went on a cycling journey that lasted for 3 days. The student recorded information about the journey using a cycling app on a mobile phone. At the start of the journey, the student traveled along a straight road to a road junction. A map on the cycling app showed the road. Figure 5 shows the map. The scale of the map is 1 centimeter to 20 meters. So here on the map you can see they've actually marked out this 20 meters. That's actually, so these 5 boxes is 1 centimeter. So from the road junction, I'm pretty sure they're going to ask about the length, right? You can see that's actually 3 of this, right? So that's 3 centimeters. Let's have a look at what they're asking. Calculate the distance traveled by the student between the start and the road junction. There you go. So between the start and the road junction, that's 20 meters, 20 meters, and 20 meters. So altogether, it's 60 meters. So that is 3 times 20. You don't really need to show the working for this, right? That's 60 meters. The bicycle has a mass of 15 kilogram. So the mass is 15 kilogram Gravitational field strength is 9.8. Calculate the weight of the bicycle. They have given you the equation weight equals mass multiplied by the gravitational field strength. So that's 15 times 9.8. 15 times 9.8 is 147. Let me just double check that. Sorry. Yes. So that's 147 newtons. Figure 6 shows a velocity time graph for a downhill part of the journey. Now, the velocity time graph is a straight line, but it's actually going straight up. The gradient of the graph represents acceleration. How does figure 6 show that the acceleration was constant? Now, the reason it is constant is because it's a straight line, right? Since it is a straight line, the reason being for it to be constant. Now, if it wasn't constant, let me show you what the graph would actually look like. So it might actually look like that, right? This is still accelerating, but not constant acceleration. This is constant acceleration because it's a straight line. If it was a straight line like this, that would be just constant velocity. Okay. A student accelerated downhill. As the student accelerated downhill, the forward force of the student was 250 newtons. The work done by the forward force was 4,500 joules. Calculate the distance traveled by the student as the student accelerated downhill. So they're asking you, giving you the equation, distance traveled equals work done divided by the force. So the work done, remember, it's 4,500. So that's 4,500 divided by the force, which is 250. And that would give you an answer of 18 meters. Most of the roads on the journey were not straight. Figure 7 shows a map of the route taken for the whole journey. So the whole journey is in a curved line. It goes up and then down and then up again towards the end. Figure 7, the line in figure 7 represents the total distance traveled when the student reached the end of the journey. How does the total distance traveled compare with the magnitude, which is the size of the displacement of the student from the start? Now, what is a displacement? Displacement is where, if you draw a straight line, right, from the start to the end, that's your displacement. So that's the displacement. This is actually the distance traveled. So the answer, the distance traveled is greater, right, than the displacement. Why is distance a scalar quantity? Distance is a scalar quantity because it only has magnitude, right? Now, if it has direction and magnitude, it will be a vector quantity, right? So you need to remember that vector quantities have direction and magnitude. So if I look at the map, displacement is actually a vector quantity. So that's a vector quantity, right? So I can measure from there, from the start to the end. I can give a value. Let's say it's 20 kilometers, right? And I can also give the direction. Remember, north, south, east, and west. And if it's going in this direction, it will be southeast direction. Figure 7 shows the distance traveled by the student each day. So on Monday, they traveled about 56 kilometers. So if you're looking at the scale from 0 to 10, there's 5 boxes. So 10 divided by 5 is 2 kilometers each box. So from 50, there's 3 boxes. So that is 56 kilometers. On Tuesday, it was 40. Wednesday, it was 62. Calculate the total distance traveled by the student. There you go. So 56 plus 40 plus 62 will give you a total of 158 kilometers. 158 kilometers. That brings us to the end of question number 3. Let's have a look at question number 4, which is on magnets and electromagnets. A student uses a special pen to write notes on an electronic tablet. There's a bar magnet inside the pen and a bar magnet inside the tablet. Figure 9 shows the pen and the tablet being held together by the magnets. I'm pretty sure most students would have a pen like this with a tablet. So you've got the north pole in the pen and the south pole. The magnet in the tablet, which you won't be able to see, is labeled X and Y. Now, I'm pretty sure they're going to ask what the poles are. There you go. The bar magnet in the tablet and the pen attract each other. What name is given to pole X and to pole Y? Give the reason for your answer. Now, remember, magnets have north pole and south pole. Now, for it to be attracted, this X should be a south pole and the Y should be a north pole. Remember, like poles attract. No, they repel. Like poles repel. Opposite poles attract. So for the pen to be attracted to the tablet, it has to be opposite poles. So pole X is south pole and Y is north pole. Reason, since only opposite poles attract, like poles will repel each other. A student investigated the maximum distance from where the pen moves back to the tablet. This is the method used. Place the edge of the tablet at 0 on a ruler. Place the pen 0.5 centimeters away from the tablet. Release the pen. If the pen moves to the tablet, repeat steps 2, 3, and 4 using a greater distance. Record the greatest distance from where the pen moves back to the tablet. So here you have the practical setup. You've got the ruler at 0, and they would have placed the pen at 10 centimeters first over here, sorry, at 0.5 centimeters first here, and then at 10, 15, 20, and you can move it by half a centimeter every single time. And at the moment, the diagram shows that the pen is at 6 centimeters. Right? Now, the ruler is saying 10, 15, 30 because it's measuring in millimeters. Right? So as you can see here, it's in millimeters. That's why it's going in 10, 20, 30. The student repeated the investigation. The distances recorded by the students were 4 centimeter, 3.5 centimeter, 4 centimeter, 3.5, and 4.5. What is the range of the distances recorded by the student? Now the range is from the smallest value, which is 3.5. They've done it twice here, and the biggest value, which is 4.5. So it's from 3.5 to 4.5. Calculate the mean of the distance recorded by the student. Now, how do you calculate the mean? You will have to add up all of those values. You have 5 different values. So 4 plus 3.5 plus 4 plus 3.5 plus 4.5. You'll have to add all of them up, and you've got 1, 2, 3, 4, 5 values. You'll have to divide it by 5. So let's write that down. So 4 plus 3.5, you don't really have to write this. When you're doing it in the exam, you can just enter it into the calculator and get the answer. So 4.5 divided by 5, that would give me 3.9 centimeters. So writing the answer as 3.9 on its own will give you the 2 marks. Complete the sentence. Choose the answer from the box. I'm just checking whether they asked you to show the working. They didn't. Repeating and calculating a mean reduces the effect of what you call random errors. Describe how the size of the magnetic force on the pen changed as the pen was moved away from the tablet. They haven't given you any values here for you to be able to answer that question. So here you should know that how did the size of the magnetic force change as the pen was moved away from the tablet? If you move it further away from the tablet, the force should actually decrease because it's not going to be attracting the pen easily. So as the distance increased, the force would have decreased. What material could the magnet in the pen be made of? Now they're basically asking for what type of material should the magnet be made. And that would be steel. Now remember, there's only 4 materials that you can make magnets from: steel or iron, right, which is steel is mainly iron. You can make it from cobalt or nickel as well. The student used 4 plotting compasses to show the magnetic field pattern around the pen. So plotting compasses are really small compasses that you often find in watches and stuff. It's about the size of a button, right? So here you got a plotting compass which is showing the arrow. Now the arrow always is the north and the tail is the south. The reason it's pointing up when you put it on the top is because, remember, opposites attract. So because if this is the north pole here, you should have the south pole. That means because you have the south pole at the bottom, they are asking you to draw one arrow inside each compass on figure 11 to show which direction the compass needle points. One arrow has been drawn for you. So the bottom one should be pointing up because the north pole will be attracted to the south pole. What about the sides? Now, the sides should actually be pointing down. The reason for that is if you were to draw the magnetic field lines, it would actually go in an arc like that, right? So the magnetic field lines go from north to south. That brings us to the end of this question. Let's have a look at question number 5. Question 5 is on waves. Some homes are connected to the internet using satellites. Electromagnetic waves are used to transmit data between Earth and satellites. Which electromagnetic waves are used to transfer data between Earth and the satellite? Now that would be microwaves. Gamma is too powerful. We don't use gamma. We can't produce that much powerful gamma to be communicating with satellites, and it's too dangerous. Ultraviolet will be absorbed by the air and things in the air. Visible light, again, it will be blocked by clouds and stuff. Which of the following electromagnetic waves has the greatest frequency? Now, the greatest frequency would be gamma waves. Now, for you to be able to answer this, you need to know the electromagnetic spectrum or the EM spectrum. The order of the electromagnetic spectrum. So remember, if I start with radio waves, then you have infrared. Oops, before I go to infrared, it should be microwaves. So microwaves, then infrared, visible light, then ultraviolet, X-rays, and then finally, if I scroll this a little bit to the side, and that will be gamma, right? And electromagnetic waves have big wavelengths, and then it actually increases in frequency. So the high frequency, so the going from left to right, from radio waves to gamma frequency increases. So does the energy, but the wavelength actually decreases. Since the waves are closer to each other. Now let's go back to the next part of the question. What is meant by the period of a wave? Now, the period of the wave is the time taken for one wave to pass a fixed point. That's a definition that you have to remember, right? The distance traveled by the wave in 1 second, we don't actually give it a specific keyword for it. The number of waves passing a fixed point each second, that would actually be the frequency. This is the frequency. And the other keyword that you have to remember is actually the wavelength, that is the length of one wave. Distance is Data is transmitted to the waves by electromagnetic waves with a frequency of 48 GHz. What does that mean? That is 48 gigahertz, right? So remember, when we are measuring values like meters, kilometers, we can actually use abbreviations. So it goes from kilo means times 1,000, which is to the power of 10 to the power of 3. Then it's mega, that's 10 to the power of 6. Then it's giga, which is 10 to the power of 9. Now we actually use the word giga when we talk about mobile phone memories and storage. So for example, your mobile phone might have 32 GB or 64 GB, right? GB is gigabytes. Here we are talking about gigahertz. Calculate the period of waves with the frequency of 48 gigahertz. Use the physics equation sheet. Now in the physics equation sheet, you will find the equation time period, which is capital T, equals 1 over f for frequency. Okay. Now 1 divided by 48 gigahertz. How do you write gigahertz? Giga is 10 to the power 9, so you would simply write 10 to the power 9 like that. Now obviously you can write it as 48 and 9 zeros. You could actually make a mistake there, that's why it's easier to write it like this. That will give you an answer of 2.08 times 10 to the power minus 11. Now time period is actually measured in seconds, so they've given you the units, so the answer for the unit should be seconds. So that's 2.08 times 10 to the power minus 11 and then seconds. 1 mark for the unit and 1 mark for this conversion correctly. If you just simply wrote 1 divided by 48, your answer is going to be incorrect, but you'll still wind up getting 2 marks. And with the correct unit, you should get 3 marks for that question, even if you forgot how to do the conversion. The satellites receive and transmit data using electromagnetic waves with different frequencies. Give one property that is the same for electromagnetic waves with different properties. Now, so different frequencies. So electromagnetic waves, right, even though they have different frequencies, that means all electromagnetic waves have the same speed, right? Have the same speed. That should give you a mark, but if you want to know what that speed is, that's the speed of light, which is 3 times 10 to the power 8 meters per second, right? You could also say they all travel through a vacuum or space. You could also say they all transfer energy. And they are also, they are all transverse waves. Next question. Most homes are connected to the internet using cables. Suggest one reason why homes in some areas of the UK are connected to the internet by satellites. Why would you not use cables in some parts of UK? For example, like places up north in Scotland and some in remote parts, right? Since cables may not be available in remote areas, right? Why would there not be cables? Well, if let's say you are living really up north and where there's not a lot of people around, there's no point in actually spending millions of pounds putting cables. So you could say it is expensive to lay cables, right? Or you could say satellites actually transfer data much faster as well. That brings us to the end of question 5. Let's have a look at question 6. Question 6 is on the topic of forces. In a dog sled race, a team of dogs pull on a rope attached to a sled. So you have the dogs, the rope, and the sled. Use the physics equation sheet to answer question 6.1 to 6.2. Okay. What equation links distance traveled, speed, and time? Now, remember, speed equals distance traveled divided by the time taken. So here they have given you speed, but they are multiplying the time and the distance traveled, so that can't be it. So the distance traveled equals the speed multiplied by the time. So if I use the symbol equation S for speed, rearrange it, the time is, sorry, the distance is speed multiplied by the time. So that is actually correct, right? If I rearrange the time, time should be distance divided by the speed. So that is incorrect as well. The longest dog sled race in the world covers a distance of 1,500,000 meters. That's 1,500 kilometers. That's a really long distance. One team finished the race in a time of 670,000 seconds. Calculate the average speed of the team during the race in meters per second. So it's already in meters and in seconds, so you don't have to change. So average speed equals the distance 1,500,000 divided by 670,000. That should give you an answer of 2.2 meters per second. That's really fast, right? So 2.2 meters per second. At the start of the race, 6 dogs pulled on the rope. The average force on the sled from each dog was 370 newtons. Now, each dog is pulling with a force of 370 newtons. So you've got 6 dogs. The backward force on the sled from friction was 520 newtons. So let me draw a really simple diagram. Let's say that's the snow and this is the sled, and your forward force is 370 newton times by 6 dogs. The backward force is 520 newton. The question is asking you calculate the resultant force on the sled. So what is the overall force? So here, first of all, you need to multiply 6 times 370 to give the total force from the 6 dogs, which is going to be One sec, let me do the calculation. That would be 2220 Newton. So the resultant force is equal to 2220 minus 520. That would give me 1700 Newton. Figure 13 shows a distance time graph for the sled at the start of the race. So you have a distance time graph, and the distance is slowly increasing, and then it's actually a straight line, right? So as you can see from there to there, if I draw a straight line, for about 6 seconds, and after about 6 seconds is actually it's a straight line, right? What does the gradient of the graph in figure 13 represent? Now the gradient, remember in maths you're taught gradient equals y over x, right? Here this is the y-axis, that's the x-axis, right? Gradient is the distance and the time. So distance divided by the time is actually the speed. Speed is the answer. Later in the race, the sled moved at a constant speed along a flat horizontal path. What was the relationship between the size of the horizontal forces acting when the sled moved at a constant speed? Now, if it is moving at a constant speed, then the forward force and the backward force should be equal. So the only answer option with an equal sign is the second one, right? If the friction and the air resistance is less than the pull of the force, then it's speeding up, speeds up. If the friction and the air resistance is bigger than the pull on the rope on the sled, then it slows down. The rope exerted a force on the sled when the sled was moving. What is the Newton's third law pair to the force on the rope on the sled? Newton's third law basically tells you that for every action there's an equal and opposite reaction, right? So to the force on the rope of the rope on the sled, if the rope is actually pulling the sled, then the sled is also pulling the rope. So that should be the third option. The force of the sled on the rope is the correct answer. Question number 7 is on forces. Now, the stopping distance of a car is affected by the condition of the brakes and tires. A car is being driven around a corner when the driver sees some roadworks. The driver applies the brakes when the car is 24 meters away from the roadworks. So the distance is actually 24 meters. The velocity of the car goes from 18 meters to 0. So initial velocity, that's u, final velocity is v. Calculate the constant deceleration force needed to stop the car in a distance of 24 meters. Use the physics equation sheet. Now, here you have to use a SWOT equation, which is in the equation sheet. Now, generally, in physics, when we talk about distance, the symbol is S. So in the physics equation sheet, you will find this equation, v squared minus u squared equals 2as. So v is the final velocity, so that is 0 squared, minus u is the initial velocity, which is 18 squared. equals 2 multiplied by the acceleration multiplied by the distance, which is 24. So 18 squared. So let me do the calculation step by step. So 18 squared is going to be equal to 324 equals, now that 2 times 24 is 48 times A. So rearranging it, A equals 324 divided by 48. So divide that by 48. That will give me 6.75. Now what happens to this negative value? That is actually still carried over. So no, because it's decelerating, it should have a negative value. So it will be minus 6.75. As a safety measure, the speed limit of the road was reduced. Explain how the safety of road users is affected by the condition of the brakes and the tires. Reduced speed. How would the safety of the road users be affected by the condition of the brakes and the tires and the reduced speed? You should refer to thinking distance and braking distance. It's a 6-mark question. So let's discuss what it actually this affects, and then we will write a proper answer. Now they're asking you to refer to the thinking distance and the braking distance. So let's start with the thinking distance. I write D for thinking distance, BD for braking distance. So thinking distance first. Does the thinking distance, is it affected by the condition of the brakes and the tires? Now the thinking distance is only affected by the person who's driving. That's it. Thinking part is done by the brain. So condition of brakes and tires does not affect thinking distance. What about the speed? Now the speed doesn't affect your reaction time, right? How fast you respond. Speed does not affect reaction time. No, but if you are going at a slower speed, then your thinking distance will be less because you're not going that fast. For the same reaction time, let's say 1 second, you would have gone a less distance at a lower speed. So reduce speed decreases thinking distance. So what about the braking distance? Right? Now, poor brakes, right? And poor tires or worn out tires. TYRES. Tires If the brakes are bad and the tires are worn out, then the braking distance or increases. Then the braking distance increases. Right? The reason, because they're asking you to explain, you have to say why. Since there is less friction between tires and road and also brake pads. Right? What about the speed? Right? Reduce speed again will decrease braking distance. Right? What about the safety? Because we haven't gone into explaining the safety, because they're asking you to explain how the safety of road users is affected. Right? How does this affect the safety? So safety. Now remember, stopping distance equals think-in distance plus break-in distance. Right? So what happens if you have really bad brakes? We've already said, if you have bad brakes and bad tires, your braking distance increases. That means your stopping distance will increase. Right? Poor brakes and tires increases stopping distance. Right? And reduced speed reduces the stopping distance. Right? So how does that actually help? Right? So reduce speed reduces the chance of driver losing control. Right? And colliding with others. Right? So there is less chance of injury. Right? During a collision with reduced speed. Last part. Two identical cars were driven along a straight level road. One car had a greater speed than the other car, so one is faster than the other one. The driver of each car applied the brakes until the car stopped. Both cars traveled the same distance while braking. Now, if they are traveling the same distance while braking, that means the car with the greater speed should have used more force. Explain how the braking from a greater speed affected the risk of the brakes overheating, right? So to stop a car with greater speed, a bigger force needs to be applied. So more work needs to be done against friction. Right? Why? Since the car with greater speed will have a bigger kinetic energy, right? So for the third mark, so the risk of overheating the brakes is higher with greater speed. That brings us to the end of this question and to the end of this paper as well. Thanks for watching. Hopefully it was useful for you. Please hit the subscribe button if you found this useful, and there's plenty of other videos in my channel and for you to use it as part of your GCSE revision. Now, if you're a higher student or even a triple science student, it's always good to watch a couple of foundation papers as well, because it helps you to revise the basic knowledge. Thanks for watching again. This is Ketish here. I'll see you in the next paper.